This is an RCA RT2500. I believe it's a 5.1 surround system stereo receiver, audio receiver, and just came out of a dumpster. I don't know what the condition is. Physically, it looks in pretty good shape. I plugged it in, and I'm going to see if we get any power. We get nothing. Unit's completely dead, so that might be a good sign. Sometimes they're the easiest ones to fix. So I'm going to open up the lid here and let's look inside and see if we can see anything that looks out of the ordinary. So stand by. Okay, I got the lid off here. Looking inside, I don't see anything that looks out of the ordinary right yet. Looking at the kilowatt, according to the kilowatt, I got 1 watt of power, but no joy on the power up. So I got a number of fuses in here. Looks like a main fuse, and here's 4 other fuses. Couldn't find a schematic for this on the internet, so I guess we'll be going in here blind. Looking at the back, you've got your 2 mains, your right and left main, front main, your right and left rear main speakers. You got a center speaker, subwoofer here, and I do have a subwoofer out here for a powered subwoofer. A lot of inputs, which is good. So this one might be worth fixing. We'll see. But the fact that I've got 1 watt, there's probably a standby power supply in here. That may be working, I don't know. This one does have a bottom panel that comes off, exposing the circuit board. Everything from this point on, so that will help doing some testing. I shouldn't have to pull the main board out to do some basic tests. Yeah. Interesting. Anyway, I guess we'll move forward to the next step. Stand by. Here's the on and off switch here. Of course, this does not switch the line on and off directly like they used to do in old receivers. And you can't do that because if you use a remote control, you've got to have a live circuit in this receiver in order to activate it. Now, personally, if I was designing this, I would have it so you could turn it off with a remote, but you couldn't turn it on. I wouldn't have a standby circuit. I'd have it so you can turn it on with a switch, and then you use your remote, you could turn it off, and then to turn it back on, you'd have to come and hit the switch again. I guess people are too lazy to get out of their chair. But anyway, that way you wouldn't have phantom power, which you have in these, because it's always connected across the line. And that's done. If you look in here, here's a small transformer here. This transformer is connected across the line. And then if you look right above it in here, there's a relay right here. And then looking in the back, these 2 connections here are where your line comes in from the power line. And if you look here, that's connected directly to the primary of a small transformer here. Here's the primary, here's the secondary, and that feeds through this fuse here. The secondary goes through a fuse, and then it feeds this bridge rectifier here that produces a DC voltage. And that provides you with a standby power supply so you can use your remote control. So the first thing I'm going to do before I go too far, I'm going to check the fuses, and then I want to make sure that this standby power supply here is active. So using a continuity tester, I want to make sure that here's the fuse for the standby power supply, and then you've got 4 fuses here. I want to check the continuity of those. That one's good. That one's good. That one's good. And that one's good. Now I've ruled out that I've got an open fuse. So now I'm going to go to live voltage here. Okay, I have the receiver plugged in now. And I'm going to look at the DC supply for the standby power supply. I should be getting, according to the bridge here, I should be getting a positive here and a negative here. Well, I'm getting 0.2 volts, and that's not right. So let me measure directly across the secondary, the transformer. We should be getting an AC voltage across here. So I need to go to AC, and I'll measure directly across the secondary carefully here. Okay, I got 12 volts AC across the secondary, but no DC voltage. So apparently I may have a bad bridge here, and this is made up, I believe, of 4 separate diodes. So I'm going to measure those diodes next. Let me do that next. Now I'll put the meter on diode test. And I'm going to measure those diodes, see if I get that diode is open. That diode is open. We may have 2 open diodes here, so I'm going to first check and see what they look like. If I can see them here. Okay, there's the 2 diodes I'm suspecting. They don't look... Oh wait, this one looks like... No, they look alright physically. I'm going to replace those 2, and we'll see what we get here. They're 60 cycle, this is a 60 cycle power supply, so I can use regular 1N 4007s. I got a ton of those. So I'm going to replace those 2 diodes here. I think I'll replace all of them. I'm going to redo the bridge here, and then I will be back. So stand by. I've replaced the 4 diodes in this bridge here, so let's see if we got any voltage on our standby. Yeah, 13 volts. Yeah, we got 13 point... Or do we? Make a better connection here. 13.8 volts. That's good. So let's see if it'll start up. Well, it looks like we got looks like she started up. I hear the relay clicking. Okay, so that was the problem. Evidently, at least one of the problems. Our startup circuit was dysfunctional. So now I'm going to hook up some speakers and let's see if we've got any output on this thing. So that will be next. Stand by. I checked the outputs for any DC offset, and that's okay. I hooked up a CD player, and whoever threw this out was nice enough to throw out some Polk Audio speakers, which is kind of nice. So I can test those out at the same time. So let's see what we got here. If I can keep from tangling things. I've got a CD in. So let's see what we get. Seems to work. Well, I think that works. I'm going to hook this up to the dummy load and crank it up so I don't upset my lovely assistant upstairs. And then I'll do some distortion measurements and that, but I think it's fixed. The problem was the standby power supply had some bad diodes in it. So, and I thought that was probably the problem because normally the standby supply works. Normally you can at least get it started and it will go into protection if you got a problem, etc. with one of the outputs, but this was completely dead. So anyway, I think we got it fixed. I'm going to cook it for a while to make sure that we don't have any problems. These are nice. The thing I like about this one is I was able to take a hatch off of the bottom, which allowed access to the bottom of the main circuit board. This whole board here was accessible from here all the way over. So that's good. Anyway, I think that'll do it for this one. If you get one of these, I hope this will help you on how you can initially check it out and get it working again. So thanks for watching, and we'll see you in the next one. Bye for now.